this video by Geneva Warner, Andrew Bramlett, and McKenna Bradley, we will teach you how to factor exponential equations.
Go.
So we have another problem that we're going to solve for x. And here's the original problem. And it has fractions in the exponents.
Scary.
Which may look scary, but you can make it easier on yourself if you pull out a common exponent. And in this case, you would pull out the smallest exponent, which in this case is 3 over 2. So you pull out an x to the 3 over 2, because they all have that in common.
Yeah, they do.
Then you take what's left, undistribute.
Wait, why is it 2?
Because it's really 4 over 2.
Oh.
And 7 minus 3 equals 4.
Yeah, that's right.
But 4 over 2 simplified is 2.
Okay, gotcha.
Same thing here. This is really 2 over 2. Alright. Because 5 minus 3 equals 2.
Okay.
And this, the x to the 3 over 2, is already pulled out.
Right.
So it's just 3. Then we move here, and we use a factoring method of grouping in order to factor.
Okay.
So, same thing here. It's like a double grouping.
All right.
And don't forget the x to the 3 over 2.
Right.
Stays. And then you can pull out an x over here.
Uh-huh.
And so you can factor again. So you still have the x to the 3 over 2. And you have x plus 1 times 2x minus 3.
Where does the x plus 1 come from?
It comes from this x right here,
Uh-huh.
plus the 1 right here.
Yeah.
And then the 2x plus 3, you group those together to get that.
Okay.
And it's all equal to 0. So then you can solve for x. This cannot be 0.
Right.
So in order for it to be 0, this x is 0. In order for this part to be 0, x is negative 1. In order for this part to be 0, x would be 3 over 2. But negative 1 is not a solution.
Would you say it's an extraneous solution?
It is an extraneous solution.
Okay.
Therefore, x equals 0 and 3 over 2.
Gotcha.
There has to be a reason that this problem can't be negative 1. So, in the very beginning of the problem, we saw x equals 7 over 2, which is the same thing as the square root of x to the 7th. And we know from early algebra that anything in square roots that is negative would be imaginary, and therefore it is extraneous.
We started.
Yeah.
Okay, so we're going to factor this problem out. It starts as 8 minus 10x to the negative first minus 3x to the negative second equals 0. Now, we learned early in the unit that whenever you see a negative exponent, you should just put it under 1, but we're not going to do that for this one because it's not the most efficient way. What we're going to do is we're going to pull out x to the negative 2 so it can become more factorable for us. So we pull out x raised to the negative 2 here. And in our parentheses we have x to the second, which 8x to the second, which if you, these two would cancel out x to the second and x to the negative second, so it would just become 8. And then minus 10 to the x, which is the same as x to the first here, and x to the first. So that 1 and that negative 2 would make negative 1. And then we have minus 3, because the x to the negative 2 has already been taken out, equals 0 again. Now this is the same as this, just expanded. This minus 12 plus 2 is the same as just minus 10. Make sure that you keep it as just x here, because we don't want to play with this. We're just trying to play with the 10 here. This is going to make it easier to group out. And then lastly we have x to the negative 2, and then bracket 4x, and then a 1, because you're going to pull out 4x here and then a 1 here to make 2x minus 3, because these two things in parentheses have to be the same for this method to work. So we have x to negative 2, and then we're going to have 4x plus 1 using these two, and then 2x minus 3. And since all we're trying to do is factor this one, then this problem is finished.
Okay, so for an overview of factoring exponential equations, it's just like factoring, but it's just ego level with all these crazy exponents and variables. You always pull out the smallest exponent. Sometimes you solve for a complicated expression. It won't just be x plus 2 times x plus 4. It'll be something like square root of log x plus 2 over square root of log x to the 4th. And also, like we did in one of the first examples, you can substitute if it helps. For example, we substituted a for e to the x. There's our many substitutions you can do. Thank you for listening to our video, and we hope you learned a lot. Bye!